Hey, welcome back to coordinate geometry. This is the revision and we consider past papers for GCSE, GCSE and problems. Alright, so that's about midpoints, that's about distances, about the gradients, right? As you remember. So the first question, okay, let's do it. Find the midpoint of the line segment AB. Alright, just simply XA xb over 2. That's x coordinate of midpoint, and for y the same. Okay, so let's calculate. -2, -4 over 2, and correspondingly 3 plus 3 over 2. So it turns out that M should have coordinates -3 and 3. Okay, that's the first question. So find the distance from C to D, alright? We'll use well-known formula, basically Pythagoras, square root of change in x delta in x coordinates. So I start from D, 0 minus 3, I'll get 3, 3 squared is 9, okay? Next one, 5 minus 2, we'll get 7, 7 squared is 49. It turns out that we have square root of 58. So we can simplify, but anyway, we can leave as a third. Alright, so and B done. Find the gradient of all lines perpendicular to line with gradient 2 over 3. Okay, so the key word that the line perpendicular to line with the gradient. So remember what we need to do in this case. We simply need to reverse the gradient of your given line. So one more time, the key property, line 1, line 2. If the gradient for line 2, 2 over 3, so for any line that's perpendicular to L2, it should have the following gradients. We reverse 2 over 3, which is basically flip it over, 3 over 2, and we put a minus sign. So we're looking for all lines with a gradient -3 over 2. So that's why that's the gradient, right? That's the final answer. Okay, so on different set of axes, show all the points with x coordinates equal to -3. So simply, what do you need to do? You need to fix x coordinate to be -3. It's here. This is x-axis. And you just need to show all the points, so basically as the vertical straight line, okay, with the equation x equals -3. So y coordinates equal to 5, so we fixed y level and put the line, put the horizontal line. So y equals 5, that's an equation. So positive x coordinates and negative y coordinates. All right, that's about quadrant. If x coordinate is positive, it's here. If y coordinate is negative, it's here. So basically, that's going to be the fourth quadrant, because if you remember, we start counting quadrants from this top right corner, and then we go on anti-clockwise. This is quadrant 4. So basically, the region between the negative part of the y-axis and positive part of the x-axis. All right, so that's the question C. All right, so next one, you have K, L, 2 points that are 9 units apart. Find M. Okay, let's do it. So basically, you have the distance between 2 points, let's say K, -3 and 2, and L with coordinates 3, M. And you know that they are 9 units apart. So what we can do, we know the distance, and we simply apply the formula, right? So we're just writing distance formula. It's better to use d squared. So basically, again, Pythagoras theorem. So d squared, we raised d to the power of 2, and then we have difference in axis, an x coordinate, so 3 minus minus 3, so I start from L, it's going to be 3 minus minus 3 squared, and then I do the same for y coordinates, m minus 2 squared. Okay, so in this case, in order to find m, it's here, so it's here, so that's why instead of distance we put 9, because d is 9, so we'll get 9 squared 81. So 81, then we transfer the whole block here, because normally we need to be left with m minus 2 squared. So 81 minus, and 3 minus 3, 6 squared is 36. That's the result for m minus 2 squared. Okay, and now what we need to do, just simple quadratic equation. So m is inside, so normally we pretend that the whole variable squared. In order to find variable, we just need to square root both parts. So 81 minus 36. So 81 minus 30, 51, and minus 6 is just 45. So square root of 45 plus and minus equals to m minus 2. Why plus minus? Because, you know, when a value is negative and it's squared, it also gives you positive value. So that's why we need to take into account basically two signs. By the way, quadratic equations should have two solutions, and that's why we use plus or minus. That basically means that we have two solutions for m. Okay, so then we transfer 2 here, and finally what we got is 2 plus minus square root of 45. So if you like, you can partially evaluate square root of 45, because we know 45 is 9 times 5. So we can say that square root of 45 is basically 3 square root of 5. So the final answer here is 3 square root of 5. Okay, that's the final answer for this problem. Okay, so we've got that. Next one, I just need more space, obviously. Okay, so let's do the next one. So if m, so we are here, if m coordinates is the midpoint of AB and A is -3 and 2, find the coordinates of B. All right, so it's better to draw. Let's say this is our segment AB, and we have a midpoint. So for midpoint we have coordinates. All right, and about A, we also know coordinates for it. So what about B? Let's say they're unknown. We just mark x and y. So okay, we're just writing the formula for the midpoint. So x midpoint equals to 1, it's here, and it equals to sum of x coordinates divided by 2, so -3 plus x over 2. All right, so y for midpoint is -1, it's here, and it equals to, we go with y coordinates, so 2 plus y over 2. All right, so we have two equations and we just need to solve them. All right, so I use multiply by 2, both parts here and here. So I'll get 2 equals -3 plus x, and here as well, -2 equals 2 plus y. All right, so from here I can figure out x to be 5, just simply transfer -3 to the left side and change the sign, and for y we have -4. All right, so we've got values 5 for x and -4 for y, so that's why it's 5 and -4. Okay, yeah, that's correct. Okay, so every time I basically advise you to draw. This is like not to sketch, just draw, put all the points in you can figure out. For those who are more advanced students, basically can complete just 2 equations and solve them. All right, so this also completed. So the last task in the block. Okay. Find the gradient of line segment joining. All right, so we have basically 2 points. Let's say 5, -1, and -2, 6. So of course, in this case, it's better to actually draw to understand how it works and to check your correctness of your solution. So it's just, we set up the first point 5 and -1. So it's somewhere here, -1 and 5. This is the first point, 5, -1. And for the second point, we'll get -2 for x and 6. So 6 is here. So that's the second point. And as you can see, so the gradient of the line should be negative because you see it's sloping down, all right? It's falling straight line. All right, so the gradient should be negative. But it's not necessarily to draw. You can use, you know, the formula, changing y or changing x. And no matter where you taking away coordinates from that point or vice versa. So indeed, let's check it. For example, this is the first point and this is the second, and we simply subtract coordinates from point 1, coordinates of the second point. So 1 minus 2. So -2, 6, yeah. We have changing y, so 6 minus -1. That's the top one, and -2 minus 5. So 7 over -7. So the gradient is -1. All right, so that corresponds to our falling dependency, falling line. Let's calculate the gradient for if we use 2 minus 1. Okay, let's do it. Now we flip them and we'll take next. So we're subtracting from 2, 1, so we'll take 5 and subtract -2, right? So in our case, it will be -7 on top and +7 on the bottom. So anyway, you'll have -1 as well. So you see, the methods where you apply to find the gradient is not dependent on like whether you're subtracting coordinates from that point or from that point. So it works a bit different. I mean, it works the same, but final answer should be obviously identical. Okay, so we stop here. I just show you only the first block, how to find midpoints, how to find distance, how to find gradients. What about like lines with the x coordinates fixed or y coordinate fixed? And we also touch a little bit quadrants and like more complicated task where you need to set up equations like in this task and find unknown coordinates. So we'll keep doing that, and so next video you'll see how to solve this part. Okay, those who can do by their own, just have a snapshot or print screen and try to do by your own. Okay guys, thank you, see you.